Hey, good morning, everybody. I want to start off this by echoing something that Ben said, and that is, when you talk about moving into a cloud environment, it's not just about can you accomplish what you're accomplishing today, but can you be more efficient with what you're doing and add more value to your business by unloading some of the heavy lifting, the muck that you used to do or currently do in your life, and handing it off to somebody else. First of all, what is Amazon Web Services? If you think about Amazon.com, it is one of three pillars in the Amazon family of businesses. Amazon.com is the retailer. Hopefully you all get smiley boxes in the mail regularly from us. The center piece of that is our seller business. That's where Amazon will hold retail packages, items for sale by others, sell them through the website, and deliver them out of our warehouses. The third piece is Amazon Web Services. We're the technology engine that underpins all of that. So if you go to our retail website, you are actually interacting with a customer of Amazon Web Services. Not only is Amazon.com a customer of ours, but they're a really demanding customer of ours. AWS is made up of a lot of different bits and pieces, services that provide everything from virtual machines to storage to networking infrastructure, application layer services, as well as the management plane that goes above them. Basically, if you think about all of the pieces that you need to run a business, we provide the infrastructure components that make those up. And then on top of that, you can run the applications, the software that you design in-house, that you buy from others, that your SIs or partners provide to you. Not only do we have a really demanding customer in Amazon.com, we have a lot of large businesses who are dependent on us to function worldwide. And it's not only dependent on us for test and development, but it's the day-to-day production environments. If anybody here is a customer of Netflix, as an example, Netflix runs on AWS. If you ever made a change to any of your movie queues or asked for a new DVD to be delivered, that happens through AWS. And it doesn't happen alone with AWS. We have a series of partners that we're happy to work with when customers want specific kinds of services, everything from working with software integrators to special development just for individual companies. The security model slide that you're looking at right now is not only an eye chart, but it's also an introduction to how we separate the responsibility that we have as a service provider from what you as a customer get to choose to do. It's a really important differentiation. We have a shared responsibility model for security at AWS. In a lot of very traditional environments, the hosting company that you might use right now is responsible from soup to nuts for security, which means that you get stuck in one model that is defined by them, and then you don't get to deviate from that if you so choose. With us, we are responsible, let's take virtual machines as an example. From the hypervisor down to the concrete is our job. So all the networks, the servers, the power infrastructure, the HVAC, the locks, alarms, guards, video camera systems, et cetera, that operate in normal data centers, we're responsible for. But the customer then gets to choose what goes on top of that, what kind of operating system you use, what applications you install, how you configure your network connections, who you expose that material to, and how you access control it. Going through the sets of information that we have here, we obviously have to have a conversation about security with the customer. And conversations have to occur in a common language. We have hundreds and hundreds and hundreds of thousands of customers all over the planet speaking not only different languages as humans, but also operating within different verticals, so different specialized areas of business, each of which has its own set of rules, regulations, and expectations for security. So the way we accomplish that conversation is through certifications and accreditations. If you look on the screen now, we've got certifications that represent typical North American interactions with companies. That's the SOC 1 or SAS 70, it used to be called, certification process. The payment card industry certification obviously is really important to us. We have a very large customer, Amazon.com, that processes a lot of credit card transactions on us. We also have a huge number of federal government customers in the United States. So the federal government FISMA accreditation process is really important to us. Our international customers have demanded that we use ISO 27001 standards for the certification process as well. The real meat of any of these, however, and the points that I want to discuss in more detail, are the control objectives that are on the slides right now. The control objectives represent the way the customer can understand exactly what we do when we practice the art and science of security. Starting off with something as dull as the security organization itself, that's my shop, Do we have the right people on board? Do they have the right training? Do they have the right authority within the organization? Do we have processes and procedures, and do we practice them on a regular basis? The Amazon employee lifecycle is one that's really kind of interesting to discuss in and of itself. In most IT shops, you have people who are system administrators or domain administrators, and they have rights to all of the machines that operate within your environment. Amazon operates in a least privileged model, which means that an employee who is assigned, for instance, to Amazon EC2, which is our virtual machine infrastructure, has rights to operate within those specific sets of machines, but no other within the company. So they can't touch the storage subsystems. They can't touch the database subsystems. They can't touch the networking equipment. Similarly, people who operate the storage plant don't have access to the virtual machine infrastructure. This is good for two reasons. From a customer perspective, it minimizes the number of personnel, of staff, of mine who have access potentially to your data. But more importantly, it reduces the chance that someone can make a mistake. Humans are fallible. They make mistakes and type the wrong thing on a keyboard sometimes. If we reduce the number of people who have access to machines, we reduce the failure rate as well as increase the security of the organization. Furthermore, employees come and go. So we have a really stringent process on maintaining status on employees within the company. Like everything else at Amazon, it's linked back to the personnel management system. When you're brought on board, you're established within the company, you get a paycheck, you also get put into a bucket that defines what is your job title. I'm a software development engineer who is on the EC2 team. That defines who your manager is and then gives you the potential to have access to machines. Your manager has to go in and say, yes, this human needs access to this set of machines in order to do their job. That's great. Makes a lot of sense. People say, okay, yeah, I do that too. But we also forcibly revoke that access every 90 days and require that the manager reapprove it. So it's not a situation where if somebody sits there and waits, they just keep their access forever. If the manager doesn't do something positive, that access is revoked. Again, two reasons. Make sure we trim things to ensure that people don't have access to stuff they don't, and reduce the chance of error. Secure data handling. We talk a lot about the management of customer data and safeguarding that. What happens when a disk drive goes bad? On storage plants the size of ours, that's hundreds and thousands, literally, of hard drives every single week. So what do we do with those drives that contain customer data? We operate, again, under simplicity makes for good processes. We have a very simple rule with our data techs. No hard drive ever leaves one of our facilities intact. That means that we degauss them and we destroy them on premise. And destroy means either shredding into pieces that are smaller than half an inch or punching with a hydraulic ram. Again, it's about how do you make sure that the person who's executing those controls can do it without really thinking about it and without making a mistake. It's given really simple rules to operate under. Physical security, really straightforward. If you've ever operated a large-scale series of data centers before, none of this is going to be shocking to you. Have the right people on the right guard staffs, doing the right things with the right locks and alarms, the right video cameras, etc., and ensure that you test them on a regular basis to ensure they're doing what you expect them to do. Environmental safeguards are all about, is the air temperature correct? Is the humidity level right within the data centers? And notice I say correct and right rather than at specific levels, because we design our facilities differently based on the age of the facility. The temperature difference may be significant. The newer facilities are much, much more efficient than older ones. We design them to a much higher standard of power usage efficiency, and as such, they run at higher temperatures. Change management. This is a fun one. How many people in the audience here are used to having to deal with patching machines? Well, unfortunately, that's something that lots of people love to hit themselves on the thumb with hammers on a regular basis. We operate under a continuous deployment model. If you look on AWS's website, you will note that there is no maintenance window or outage window listed for any of our services. We don't have them. The way we operate is that we believe that all of our services have to be available all the time, and we design our deployment processes to accommodate that, as well as the patch and remediation process. So the way we do the change management process is, if I'm a software development engineer and I'm on the S3 team, which is the storage infrastructure team, and I make a change to set of software that I'm responsible for, it goes through a series of tests on my local network that my team works on. If it passes that series of tests, it progresses into a beta environment. In that beta environment, there is a well-understood, well-processed series of integration tests, of unit tests, of performance tests that it has to go through. And once it's passed all of that gauntlet of things, it can be rolled out into the production environment. Now, the fun thing is rolling out in the production environment starts off with something we call a one box. Literally, you take that set of software and you place it on one machine in one availability zone in one region on the planet, and you bake it there. You make sure that it functions as you intended, and it does what you expected in terms of load. If it passes that test, you can roll it out to the other machines in that same availability zone, and again, wait. See if it does what you expect, and then roll it out to one availability zone at a time in each region. Cardinal rule, never touch multiple availability zones in one region at the same time. And I'll get to what an availability zone in a region is in case you're not familiar with it in just a sec. Data integrity, availability, redundancy, these are all elements you're all very familiar with. This is, do the checks that we have to detect changes in the environment work? Do we have the appropriate checks in place to ensure that the storage systems are backing things up, or in cases where they don't back them up, where they're continuously available? Making sure that the process of bit rot detection is in place, as well as ensuring that we have the redundancy or availability profile that we expect for our power systems. Incident handling is the last bullet on that slide. Incident handling is what happens when something goes bump. And something could go bump because there was a major electrical storm, or it could go bump because there was a security incident. In either case, we have to have processes and procedures, and we have to test them. And testing them is something that I take really, really seriously. We do what we call game days on a regular basis. A game day is a situation where literally we will go in and inject logs into a security system which indicate that there's a problem going on somewhere, and see if our staff reacts appropriately. Do they detect the event? Do they process the event properly within the time frame that we've established for them to do so? And do they react the way we expect them to? And can they get hold of all the people that they need to in order to process that event? So literally, it's the same way that if you were running a security checkpoint and you were looking for firearms and luggage, you would surreptitiously insert a firearm into luggage to see if your staff detected it. We do the same thing in the logical world. We insert virtual firearms into the log stream to see if our personnel process things appropriately. I'm talking through a lot of stuff today, a lot of which is really dense and has a significant amount of material behind it you have to digest and understand. I encourage you to take a look at our security website, aws.amazon.com/security. There is a security white paper on there which goes into a lot of detail about exactly how we protect your information when it's entrusted to us. Furthermore, there's a risk and compliance white paper on there that's specific for individual verticals. So if you're a healthcare business and you want to process HIPAA-protected personal health information, there's one there that can help you out. There's a how to process credit cards appropriately on AWS white paper as well. Now, one of the fun things about working at AWS is the velocity of change is incredible. Last year, I think it was 52 major feature enhancements or new service launches came out. So we have to regularly update all of the security documentation that we have. So as such, if you check out our security center and you're a customer of AWS, please check back regularly to see if we've enhanced the documentation to give you more information. Lastly, on the security resources piece, I want to know what you think about it. If there's stuff that you like, let us know. If there are pieces that you would like to know more about, or if there are details that you think are omitted that are really important to you, we'd love to hear. Give us a shout. There are contact processes detailed on that website. I encourage you to use them. This is all about how do we make sure you understand exactly what we are doing. Our infrastructure is global. So on the screen, yep, you've got it in blue. Our global infrastructure locations, the orangey yellow boxes are where we expose our regions to customers. So a region is a macro geographic and geopolitical box into which we place availability zones. Availability zones are the equivalent of data centers. I say equivalent to data centers because in some of our larger regions, a single availability zone may actually be multiple physical buildings because it's so big. An availability zone is a construct that allows you, the customer, to decide how you deploy your infrastructure to determine the level of availability, redundancy, and throughput that you want for your particular application. So, for instance, many customers say, this is a dev test environment. I'm not as concerned about availability. If that building gets hit by a meteor, I can be without it for a few days. Whereas this particular thing represents my SAP production environment. That absolutely has to be up and running all the time. So I'm going to deploy that to 3 availability zones within a particular region. The other thing that's important about regions is it represents a geopolitical box into which you put your information. So we've got a number of customers, notably the U.S. government, who say, I want you to guarantee my data never leaves the United States. If you use one of our U.S. regions, we'll say that, absolutely. Similarly, we have a large number of customers who say, I don't want my data in the United States, in which case we're happy to accommodate them in other regions around the world. Identity and access management. You work in your business within a set of confines where you put people in jobs and those jobs have roles. We have the same ability within AWS. You can say that Bob is in an administrative group, so he can do the following things with just this set of hardware, but he can't touch the dev and test hardware, whereas the dev and test guys can't touch the operational hardware or storage, etc. We don't have enough time to go in detail through the EC2 security slides. I'm happy to talk to folks if they'd like to later on about this. The bottom line is that our staff don't have access to the virtual machines at the administrator or root level. That's something the customer has to choose to allow us to have access if you want to. The customers control root level access there, and you generate your own key pairs if you want. It's a really smart thing to do. It's something in our best practices. We strongly encourage you to do it. Network security, lots of questions about DDoS when I talk to folks. It's something we have to deal with on a regular basis. In fact, we have an automated DDoS mitigation system so that when we see certain types of behavior targeting customers' information, we can mitigate it before the customer even notices. The fun part about this is, though, that we have to be very careful about what we call a denial of service attack. The canonical example of this is that when Michael Jackson passed away, we had a customer set of virtual machines who saw a huge spike in traffic. And we thought, wow, gosh, they're really getting attacked by somebody out there. Turns out it was his record label who'd stood up a tribute site on AWS without talking to us, which of course is perfect. That's exactly the way we want our customers to interact. But if we had shut down that traffic, it would have shut off completely legitimate traffic. So we have to be very careful about how we define what is inappropriate traffic, since our customers are widely diverse. Otherwise, we do a lot to police outbound traffic as well. If you do annoying things on our network and try and break into other people's systems, we will notice. We will come and talk to you and ask you why you were doing that. However, we also support penetration testing using our infrastructure. We have partners who do that as a business, and there's a procedure that they can go through so that we turn off the automated throttles and permit them to do the kinds of testing that they need to process their business. In fact, we encourage all of our customers who run infrastructures to consider the use of penetration testing as a smart security technique for protecting your business and your information. Virtual private cloud. This answers the question from a customer in New York City who came to us and said several years ago, I have 9 data centers. I want to get rid of one. I want to run on the cloud, but I want to use the same kinds of processes that I currently do. I want to use the same management infrastructure I currently do, and I want it to look like my existing data center. So literally, VPC allows you to carve off a piece of the cloud, set up your own network infrastructure in there. You can use your own IP space if you want to. You get to define the path the packets take to and from individual subnets. You get to define how the data gets in and out of the cloud. You can make it a lollipop if you want, so the only place that traffic can go is back to your premise. It can't go out to the internet. It's really a data center in a box or on a stick, and you decide how you want to deploy it. Last bit is people often say, well, you've got this US GovCloud region, which is certified for use by sets of folks who are subject to ITAR, which is International Traffic in Arms Regulations. It's specifically for US government users as well as US government affiliated contractors who are doing research. What's the difference in security between that and the public commercial cloud? The only difference between the two is what's noted on the slide there. The government facilities run on their own network in their own boxes, literally, and the personnel who have access to it are U.S. citizens. That's the only difference in operations between the two. Otherwise, there's no reduction in security for the commercial infrastructure. You get to take advantage of the same security that's available for U.S. government resources. Okay, the last bit, I got to look at my little paper here because I was given a note at the last second here. The breakout session that's up on the slide right there, please join us. Ted Meyerson, who's the SVP and Global Head of Access Services for NASDAQ OMX, is going to be discussing how the world's largest exchange is using AWS to deliver transformative IT solutions to the financial services industry. So please stop by our booth, say hello, ask us questions. We'd love to talk to you and love to learn more. Thanks very much.